Today, we're demonstrating end-to-end AI pipeline using NVIDIA GPUs, a secure end-to-end pipeline using Intel TDX in conjunction with those GPUs. What we're going to illustrate here today is a user essentially leveraging an AI web interface to create a query. And what we'll see on the back end is the actual activity here on the right-hand side of the screen. The goal of this is to prove that TDX delivers security to help protect models like this. And so the front end is what the user sees. They go ahead and they log in, and I'm going to fast forward us a little bit, and they issue a query into that AI using the web interface. Can an unauthorized person dump virtual machine memory? Okay. When we up-level that query and send it to the AI model, what we actually see is that some load is generated on the server. Both the GPU and the memory get exercised. Now, by virtue of that, we can try to dump the CPU's memory and see if we can find any of this data in that dump. Now, remember, we don't have any confidential computing active. This is a plain Jane VM with just a standard NVIDIA unprotected GPU. And we're scanning the dump right now. It's a large file. It's the entire memory space of the VM. And what we will find in a moment here is that in red, we actually found the query. We actually see the user prompt, we see the assistance response. And so essentially, without confidential computing, this VM is actively leaking data, okay? Now the next move will be to activate confidential computing. What will happen here is the VM that's running will be shut down and respawned with confidential computing active. Both the CPU and the GPU will actually have confidential computing enabled, and they can securely communicate to one another using a custom bounce buffer driver that's unique to Intel and NVIDIA. So as we wait for this to come up, let me just fast forward a little here. Okay, our user's going to sign into the web AI again, and when they do, they're going to issue another query. You can see, give me the definition of trust domain extensions and key features. As Minstrel responds, you'll see again load on the CPU and GPU and the memory. And then we're going to go ahead and do another memory dump search. So basically, we're going to dump the RAM of the running VM and search for that same query, just like we did last time. And so as the machine dumps the memory and we start scanning it, you might be able to predict that thanks to confidential computing, we're going to see that no matches were found in the entire file. And so essentially, the memory encryption protecting the CPU and GPU have prevented this would-be hacker from scanning the memory dump and finding any information of value. The dump itself is filled entirely with zeros because the memory addresses are essentially blocked because this user is not the correct user, the valid user to access those items, and therefore is prohibited from doing so.